Hey, welcome to The Explainer. Today we're going to break down something pretty wild, how a surprisingly small AI model is delivering top-tier performance, totally challenging this idea that in AI, bigger is always better. So what you're looking at here is a classic David versus Goliath setup. In one corner, you've got this absolute heavyweight, a monster of a model with 671 billion parameters. And in the other corner, a challenger that's over 40 times smaller. You'd think this is a total mismatch, right?
All right, so here's the question. Which one is actually better at cracking some of the most complex math problems out there? And I know what you're thinking, the big one, obviously. But you are in for a surprise. And what's really cool is that the answer points to a massive shift in how AI is being built.
Okay, so to really get why this is such a huge deal, we need to talk about the way AI reasoning usually works. For years, the main strategy has just been to make AI models think longer. But that whole approach, well, it's starting to hit a wall. For a long time, the go-to method has been something called chain of thought. The idea is pretty simple, actually. To solve a hard problem, you just have the model write out every single step of its thinking. It's kind of like when your math teacher made you show all your work. It just thinks and thinks until it gets an answer. But, and this is a big but, this whole approach has some major flaws. You see, it's super easy for these models to make one tiny mistake right at the beginning and then just run with it, going down a completely wrong path because they're not great at correcting themselves. And that means you often need these gigantic, super inefficient models to just brute force their way to a solution. So here's the bottom line. Just making models bigger so they can think longer, it's just not going to cut it. So that brings us to a totally new way of thinking about this. What if, instead of just thinking more, the AI could act more like, well, like us, like an expert who doesn't just sit and ponder, but actually does stuff to figure things out? And that right there is the core idea of an AI agent. It's a model that doesn't just get lost in its own internal thoughts, it actually gets its hands dirty, so to speak. It can use tools like a calculator to check its own work, and it learns from feedback, whether it's a success or an error. And this whole thing works in what's called an agentic loop. It's pretty cool. First, the model thinks about the problem. Then, instead of just thinking more, it acts. It writes a little Python code to test a solution. Then, the environment gives it feedback like, hey, that worked, or nope, error. And finally, the model reflects on that feedback and tries again. It's this constant loop of think, act, learn, repeat. Okay, so how did the rStar2-Agent team pull this off? How did they make this loop so incredibly good? Well, they didn't just build an agent. They totally perfected the way it learns with 3 key innovations. All right, they had 3 keys to their success. They built a super fast system for using tools, they came up with a brand new training algorithm, and they designed this really smart training plan. They're all critical, but honestly, that second one, the new training algorithm, that's the real secret sauce here. Let's dig into that. Okay, it has a super long name, GRPO-RoC. Don't worry about the acronym. Just think of it like a world-class coach. They don't just high-five you for winning. No, they pull up the game tape and only focus on the plays where you were absolutely perfect, the ones that were clean, efficient, and just flawless. And here's what that actually looks like. A lot of other methods would reward any correct answer, even a messy win. You know, the kind of win where you trip over the finish line, full of mistakes. But this new algorithm? Nope. It filters all of that out. It forces the AI to learn only from the clean wins, the perfect runs, the elegant, efficient solutions. So the idea is brilliant, right? But does it actually work in the real world? Let's get to the proof, because the numbers are where this story gets really exciting. And the results? Well, they are pretty mind-blowing. We're looking at scores from the Amy math benchmarks, which are notoriously tough. On the Amy 24 benchmark, the little 14 billion parameter rStar2-Agent, it didn't just hang with the 671 billion parameter behemoth. It actually beat it. I mean, just look at this chart. It says it all. The smaller agent is at the top of the leaderboard, beating out not just the giant DeepSeek model, but also the super capable Claude Opus. It's definitive proof that working smarter can absolutely demolish working harder, or in this case, just being bigger. And get this, it's not just about getting the right answer. It's about how it gets there, because it learned to find those perfect, clean solutions. Its answers were, on average, 35% shorter. It's getting the job done with less wasted time and energy. It's literally thinking smarter, not harder. So what's the big picture here?
what does all this mean? Because this isn't just about one model winning one contest. This is pointing to something much, much bigger for the future of AI.
What we could be looking at is a major pivot for the entire field of AI. It's a shift away from this bigger is always better arms race and toward creating smarter, more efficient agents that actually learn from interacting with the world. And listen to how the researchers themselves put it. They say the model shows advanced cognitive behaviors. So the AI isn't just a calculator spitting out answers anymore. It's exploring, it's checking its own work, and it's refining its own thought process. Which leaves us with one last big question to chew on. When we build systems like this, where an AI can use tools, make mistakes, and learn from feedback, are we just teaching it to follow a long set of instructions, or are we finally teaching it how to actually learn?